The weather industry just lost its last excuse. In May 2026, ECMWF, the European Centre for Medium-Range Weather Forecasts, the single most respected meteorological body on the planet, officially promoted AIFS V2 to primary operational status. Not experimental, not running alongside the old system as a cute side project. Primary. And the traditional numerical weather prediction community is pretending this is fine. It is not fine. It is an extinction event for an entire way of doing science, and the people most affected are the last ones willing to say it out loud. Here is who the villain is, and I say this with respect for their historical contributions: the NWP establishment. For over 40 years, atmospheric scientists have built careers on writing and maintaining hand-coded partial differential equation solvers. The integrated forecasting system at ECMWF alone has millions of lines of Fortran. Governments have spent billions on dedicated supercomputers to run these models, and an entire academic ecosystem, journals, tenure tracks, conference circuits, depends on the assumption that you need deep domain expertise in fluid dynamics to forecast weather. AIFS V2 just told all of them that a transformer-based architecture trained on Era 5 reanalysis data can match or beat their life's work with a single forward pass of inference that takes under 90 seconds on a handful of GPUs. Let me give you 3 pieces of proof that this is not hype. First, verification scores. ECMWF publishes scorecards comparing models on metrics like RMSE of 500 h-pod geopotential height and anomaly correlation coefficients. AIFS V2 now matches or exceeds the legacy IFS on nearly every lead time out to 10 days. That is not cherry-picked. That is their own internal verification, published on their own website. When the institution that built the old model tells you the new model is better, you listen. Second, computational cost. The IFS requires a massively parallel simulation on thousands of CPU cores, consuming hours of wall clock time per forecast cycle. AIFS V2 runs a learned forward pass. We are talking about a reduction in compute cost that appears to be roughly 3 orders of magnitude. That is not an incremental improvement. That is the kind of efficiency gap that makes entire infrastructure categories obsolete. Every national meteorological service running its own billion-dollar supercomputer for NWP should be asking very hard questions about their next procurement cycle right now. Third, fine-tuning and adaptability. Traditional NWP models are rigid. You want to add a new variable. You rewrite physics parameterizations, revalidate, and pray you did not break something downstream. With a learned model, you fine-tune on updated data. You adjust the architecture. You retrain. The iteration cycle collapses from years to weeks. This is why ECMWF was able to move from AIFS V1 to V2 so quickly, incorporating diffusion-based ensemble generation that the original architecture did not have. Now, if you are watching this and actually learning something the mainstream meteorology press will not say this bluntly, subscribe. The people doing the real analysis should not be harder to find than the ones sugarcoating it. Here is the counterargument, and it is a legitimate one. Extreme weather. The skeptics say a learned model trained on reanalysis climatology will underpredict rare, high-impact events because those events are underrepresented in the training distribution. That is a real concern. But here is what they leave out. AIFS V2 uses a diffusion-based ensemble strategy that explicitly models forecast uncertainty by generating multiple plausible trajectories. Early verification from ECMWF suggests its probabilistic skill on extreme precipitation events is competitive with the IFS ensemble. And in some cases, it appears to capture spatial uncertainty patterns that the physics-based ensemble misses because the IFS ensemble relies on singular vector perturbations that are themselves approximations. The counterargument is not wrong in principle, but it is losing on the evidence. So here is where we are. The most authoritative weather forecasting organization on Earth has decided that a neural network is now its primary tool. Not a supplement, not a backup. The tool. The people who spent decades building the old system are still employed, still publishing, and still insisting this is all complementary. In my analysis, that is the same denial pattern we have seen in every field that gets automated. The institution moves on. The workforce narrative lags behind by 5 years. The question is not whether ML weather models work. That debate ended in May 2026. The question is what happens to the thousands of atmospheric scientists whose expertise is in writing the code that just became a legacy system. So tell me, should National Weather Services keep funding traditional NWP development? Or is that money now better spent on ML infrastructure and retraining their workforce?